Good afternoon, good evening or good morning. This is going to be a full work through of the 2018 paper 3HR. Quick disclaimer before we start, you should not be using this video if you have not already attempted the paper yourself. Having worked through the paper unseen is the most valuable part of these past papers. If you do use this video, please feel free to pause every time you get a hint that you are maybe missing. Make sure you're having a go at the questions either before or pausing and having a go as we do together. I can't guarantee that this is a flawless paper solution. If you do notice anything wrong, any mistakes anywhere, please do let me know. Without any further ado, let's start this paper. At the beginning of every exam, you should always be checking the front. Remind yourself of the instructions. We should be showing all of our working. Calculators are allowed. If you haven't made yourself incredibly familiar, you should do so with the formula sheet to know exactly which formulas you need to know and which ones are given to you. As we move to question 1, work out the value of that. I've got my trusty calculator to the side. A really good hint with this one is to hit the fraction button very early so that you can type the numbers into the top and into the denominator. Hitting equals, it's asked us for all of the figures on my calculator display, so I'm going to do exactly that. Already putting the decimal place in the wrong position. Write your answer, now correct to 3 sig fig, or the 4 at the end there is our third significant figure. The 1 afterwards tells us to leave the number alone. Question 2. Helga has played a game many times. She scores 9. In 5/6 of these games, she's going to play the game another 60 times. I'm already starting to think this is probably expected frequency. Work out an estimate for the number of times she'll score 9 or more in these games. So 5/6 of the games she scores 9 or more. She's going to play that game 60 times. A simple multiplication gets us that we expect to get that score in 50 games. Now we need to sketch a graph. Many ways to draw these straight line graphs. Probably the most simple is to create yourself a quick table of values. Various x values, various y. I'm just going to check the graph. Graph goes between -1 and 3, so those are going to be my choice of x values, and the question actually says it up at the top as well. Now we just need to sub our x values into the formula to get our y values. Subbing -1 in, we get 4 minus -2. Subbing 0 in. Now already I'm spotting that these numbers are going down by 2 each time, matching the fact that our gradient of this straight line is 2. Plotting some of these values, 1 minus 6, 0, 4, 1, 2, 2, 0, 3 minus 2. And of course in the exam you will have a ruler to join those up much more smoothly than I can on the iPad. Write coordinates of the point where that graph crosses the line y equals 1. So I'm going to draw the line y equals 1 also onto my picture. One thing I didn't do in the previous part was name my line. Incredibly useful thing to do. So now I have my 2 lines. I can look where they cross, and as you can see my line was not great. I didn't quite hit that 2. So they are actually going to cross at this position here, even though my lines didn't quite line up too well. X coordinate 1.5, Y coordinate 1, and we're happy. Question 3, quite an unusual question this, talking about cogs. We have 32 teeth on A, 24 on B. Both the cogs are going to rotate. A completes 12 full turns, while B completes 16. So that's telling the ratio of cog turns to cog turns. So for A to B, we're currently 12 to 16. We want to know how many full turns that A will do if B completes 60. Well, we can look at our ratio to get from 16 to 60. I multiplied by 3.75. I've got that simply by doing 60 divided by 16. On the other side, exactly the same has to happen. We're multiplying by 3.75. 12 lots of 3.75 takes us to an answer of 45, and A is going to complete 45 rotations. Notice we didn't use the teeth for this calculation, but that 24 to 32 is identical in ratio to 12 to 16. A bit of extra information than what we actually needed for the solution. We're now into angles in polygons. We've got each exterior angle of a regular polygon. Regular meaning that all of our exterior angles are the same. We need to recall here that the total exterior is 360. So that's saying that 360 is 24 times the number of sides. So our number of sides, 360 divided by 24. We have 15 sides on our polygon. We now have a pentagon. We're missing one angle. Notice we do know that both of those are 90. So we're going to have to work out the total angle inside of a pentagon. So we need to remember the formula. Total interior angle is n minus 2 times 180. Where n is the number of sides, so that's 5, subtract 2 times 180 gives me a total interior angle of 540. But we already know most of our angles, so this 540 is the total angle so far. We've got two 90s, a 137 and a 128, and this unknown t. So now into my calculator I can do the 540 and just subtract off all of those other angles, giving my angle of 95. Now, although the diagram is not drawn accurately, it at least appears that this t should have been obtuse, and a 95-degree angle seems reasonable. Question 6. A bit of set theory going on here, but in the context of fish. So everything we care about is the fish in Jake's Lake. We're looking at A as the set that are long, B are the set which are heavy, and C are the set which are young. He catches a fish which is 2 years old, weighs 1.2 and is in 19 centimeters in length. Which set is this fish a member of? Well, 19 is too short to be in A. 2 years old is too old to be in C. So the only set that we have is set B. Unfortunately, this looks like one of these artifacts of the formatting. I believe that E should in fact be the intersection. Actually, looking at the next part of the question, this is more likely to be the union, because I believe that one down there should end up being the intersection. If it's not the union, I apologise, but that's what I'm going to interpret this question as. So describe in words fish that are members of A union B. Well, union is or, so this is going to be fish longer than 20 centimeters, which was A's condition, or B was or heavier than 1 kilogram. And A union B is both of those. Now B intersects C is saying that those which are more than 1 kilogram and younger. So saying that that is the empty set is saying that the young fish are quite light, which seems reasonable. This is saying that the younger fish, and by that we mean less than 1 year old, so that's C, are lighter than 1 kilogram. So it's saying every young fish, so if you're in C, you cannot be also in B. Young fish are lighter, which definitely does seem reasonable. We have an algebraic expressions linked with area and perimeter. Seems to just be perimeter for this question. We have rectangle and isosceles. You can see it's isosceles because we've got the same side length on those. Write down expression in terms of x for the perimeter of the rectangle. Well, the first thing to notice is we've got these opposite pairs. So we have an extra 4x plus 1 up there and an extra 2x plus 2. So we need to add these 4 expressions together, collecting like terms. I'm going to have 8x from the top and the bottom, an extra 4x, which makes 12x. Got 2, 3, 4, 5, 6 as my numbers. Incredibly similar for the perimeter of the triangle. Again, we've got 4x this time and an extra 6. The perimeter of the rectangle is equal to 2 times the perimeter of the triangle. So my rectangle perimeter, I already have the expression for, is equal to 2 times the perimeter of the triangle. Well, I've just created myself a fairly simple linear equation to solve, expanding the brackets, moving the x's over to the left and the numbers over to the right. I've just subtracted 8x and subtracted 6. Dividing through by 4 gives me my answer of 1.5. And check the units. Yep, the measurements were in centimeters, so 1.5 centimeters is our value of x. Now, as we go back to check our work, we can sub that 1.5 back into our 2 expressions to confirm that the rectangle was indeed twice the triangle. Question 8. We have a dog breeder. 32 dogs gave birth to some puppies. And here we have how many puppies born to each dog. Firstly, we're asking for the modal class. Modal class is the one with the highest frequency. Well, that's our 4 to 6 as the frequency of 12. We now want to work out the estimate for the mean number of puppies. And this involves adding the extra column on that I like to call fx. Now, before we actually need the fx, we'll notice that these are grouped frequency table, so I actually need my midpoint first, and then I'll have f times the midpoint. If these were just given values rather than ranges, we could use fx straight away. Now the midpoints, the middle of 1 to 3 is 2, 4 to 6 is 5, etc. And this is where the estimate comes in. We don't know all 5 of the first section. We didn't know all of them had 2 puppies, but we're estimating. Now multiplying across to get our fx column. It's fairly simple. The numbers aren't too tough, but of course we do have the calculator to help us out. Now mean is then the total divided by how many. Well, the total is going to be the total of this f times midpoint column. So I need to add up that final column, and this one I am going to use the trusty calculator, and I get 208 for the total of that column. The total frequency is the total of this column here. Or just notice that the question has already told us that total is 32. So the mean is roughly that total divided by how many puppies? 208 divided by 32 comes out as 6.5. So on average, these dogs had 6.5 puppies. And to confirm before we move away, that does look about right. Most of our data is in this 4 to 6 region, so we'd expect our answer to be in that region as well. Finally, we get our show that question for fractions. Again, an unfortunate artifact of the formatting meant we don't actually know what calculation we're trying to do here. So I'm just testing with my calculator to see which one actually gives the right answer. And indeed, it should be a divide. So it's a show that we need to do every step very carefully. First step, we have mixed numbers. We need to convert them into improper. So we're going to multiply and then add the top. So our first is 3 times 8 plus an extra 3. 27 over 8 divided by, same for the other one, 4 times 2, add the extra 1. Now divides we can't do directly, so we use KFC, keep the first one, flip the second one and change to a multiply. Now that we've got multiplies, we can start cancelling, cross-cancelling common factors. I can see a common factor of 4 on that diagonal and a common factor of 9 on that diagonal. That's leaving me with 3 over 2, and 3 over 2 is indeed 1.5, the answer that they needed. You don't need to write a huge amount of work in, but you do need to show every step very clearly for these show that style questions. Quite unusual that that's as deep as question 9 in the paper. Now we've got a right angle triangle. We've got no angles, so the only thing that's really useful for right angle triangles is our good friend Pythagoras. So Pythagoras is going to say that the sum of the squares on the shorter two sides equals the square of the longer. Now I'm looking at this and I don't recognize this as a nice Pythagorean triple with all whole numbers, and the question is asking for 3 sig figs, so this isn't going to be a particularly pleasant number. 15 squared, take away the 11 squared to isolate the x, gives 104, so x is the square root of 104. Good habit to write it exactly once before writing out the actual answer, and my calculator gives me to 3 sig fig 10.2. I'm just going to make sure the examiner knows that I did think about it and I have rounded to 3 sig fig. 11. Starting to get into some of the meatier questions. The line L has that equation. We want the gradient. Well, equations of straight lines, we have to be thinking of y equals mx plus c. So our first step is to rearrange this into y equals, getting rid of the 4x, isolates the y term, dividing by 5, gives us y equals, and the gradient is the value in front of the x, which in this case is negative 4/5, or negative 0.8 if you prefer the decimals. The line M has a gradient of 2, and they both cross the y-axis at the same point. Well, the y-axis is our y-intercept. So for L, we know that L crosses through with that number at the end of y equals mx plus c. So L goes through 0, 4. Well then, y equals mx plus c. For M, we already know the M is 2. Also has to go through that y-intercept. of 4. I'm going to take a quick check to see if there was more that I needed to do. I didn't use much of the working space, but for only 2 marks, I think there can't be too much more going on with this one. Question 12 are circle theorems. PQ, and S are on a circle. Straight away, that's a 4-sided shape. That's a cyclic quadrilateral. I'm thinking about opposite angles adding to 180. And it's told me a couple. I want to find the angle PSR, which is that one up there, which indeed is opposite to one of the ones that we have. So straight away, that angle is going to be 180 minus 78, which is 102. That's because opposite angles in a cyclic quad add to 180. It's worth making sure that you've absolutely memorized all of those circle theorems and the correct wording for each of them. We now want the angle PSQ. Well, PSQ isn't actually a line that we already have, so I'm just going to get rid of some of this extra scrap I put in and put in that extra line. So we're wanting this angle PSQ up there. Now it might take you a while to spot the kind of shape we have, but let me highlight the useful, and we can actually see that we have the beautiful bow tie going on here. So actually the angle is the same as that one over there. Well, the angle up at R, we have a triangle already. So PRQ is the triangle, the 180, take away the 2 angles which make it up. Should have brackets around those because I'm subtracting both of them. And that gives me that the angle up at R is 40, but then the bow tie angles in the same segment are equal, so that PSQ is also 40. This question didn't ask me to give a reason, so I'm not going to. 2 marks for getting that there. Cumulative frequency graph. Now, unfortunately, because this is a PDF, I'm not quite sure where the staples are, but I imagine that we've pretty much come to the middle of the paper by now. The cumulative frequency graph shows information about the number of calories used by 88 people. That's going to be useful. Not a pleasant maximum, but that's what we're going to have to use for the exercise program. Use a graph to estimate the median number. So median is halfway up. Well, that's where that 88 comes in. We need to go halfway up. Now, the first thing to notice is the scale. 10 little boxes make 20, so each little box is 2. So 44 is 2 little boxes above 40. And again, because you guys will have a pencil, ruler and a hard copy of this, you'll be able to draw these lines much straighter and cleaner than I will ever able to do on the iPad. Reading that off, we get 350. We're also then going to estimate the number of people who use more than 500 calories. So I'm going to look at my 500 calories, go up and across. I'm drawing my arrows on the grid. That is my working for these kind of questions. This time I'm going up and then across. So 80 used less than 500, but we want those who used more. Well, there are 88 people in total, so there are 8 people who use more than 500 calories. 14, a very simple inequality for being this late in the paper, multiplying through by 4, and we get our first answer. The second one, however, is a lot sneakier. This is a quadratic inequality, despite it looking relatively simple. For quadratic inequalities, we solve the equality first, which isn't too unpleasant. Remembering that when we square root anything, we need plus or minus. Then a quick sketch of the graph. I'm just going to rewrite this as the quadratic greater than 0. Quadratics always want to be compared to 0. So this is a positive quadratic which goes through plus or minus 3/4. We want where it's positive, i.e. where the quadratic is above the x-axis, so it's those two regions. So that's q is greater than 3/4 for the right hand region, or q is less than negative 3/4 for the other side. Now if you're still unsure, you can test some values. A very simple value to test that's bigger than 3/4 is 1. 1 does work in the original, so we've got the right region. A cylinder has height and diameter. Well, this is one of the formulas which you might have in the front. The cylinder volume is given by pi r squared h. So subbing in those values, pi times, well, we were given the diameter, need to be a way you can turn that into the radius, and that's the calculation which I'm going to type into my calculator, and the question does want it to 3 sig fig. I'm going to write the exact answer once, just to show the examiner that I do have the correct value, and then the 3 sig fig rounded answer on the answer line. We've now got into what the question is actually wanting, which is similarity. Cylinder B is similar, the height is 12, so my scale factor is 21 over 12. Try and at least write that nicely. Now I'm a big fan of always doing the big divided by the small to get my scale factors. Now we want the diameter of B. The diameter of B is going to be the diameter of A, which was 8, multiplied by the scale factor. I don't need to adjust it. Everything here is just lengths, which gives me 14 centimeters. Cylinder C is similar to A, but this time we've been told about the volumes. And we've actually been very explicitly told the volume scale factor is 64. To get from A to C, I multiply by 64. Well, I don't want to deal with volumes. I want to deal with lengths because I want the height of C. And you'll recall, to get to the length scale factor, we cube root. 64 is a cube number. Cube rooting is 4. So that's saying that cylinder C is 4 times as big. So that the height of C is 4 times the height of A, which I'm checking that I'm not going to misquote, is 12, giving C a height of 48 centimeters. Question 16, we're into percentages. Daniel buys a new car. First year decreases by 24%. The value at the end of the first year is 13,300. We want to find the original. Lots of hints here which I'm trying to highlight. So this is all a reverse percentage. A decrease by 24%. Well, we start with 100%. We take off the 24. And we are left at 76%. So my multiplier is 0.76. To go forward we multiply, to go backwards we divide. So going back to the original value, we're dividing by that 0.76, and it's always a good sign when your answer comes out quite nicely. The value of the car is reminding us that it's 13,300. The end of the second year, third, etc., it decreases by X%. End of the fourth year is 6,500. So this is a backwards compound depreciation going on here. Recalling our formula, it's the initial times the multiplier. I'm just going to call M here to the power of how many years. So we've gone to the second, the third, and the fourth year. So we've had 3 years with this multiplier, giving us an answer of 6,500. Now it's just an equation to play with. M cubed is a horrible fraction, so my multiplier is the cube root of that. It's 0.787, etc. Now we need to decide, well, what was the decrease that causes this multiplier? Well, I always start with 100%. 100% minus this 78%, and we want x correct to 3 significant figures. So if I do 100 minus, well, I need to times that by 100 to turn it back into a percentage, minus this 78.7 dot dot dot. I'm using the answer in my calculator. Comes out as 21.2% to the 3 sig fig that they care about. So in the following years it does lose slightly less value than it did in the first year, which is a common for these kind of problems. Question 17 is a differentiation, quite early in the paper for differentiation, but that does show that we're really getting into the meat of the difficult questions. Differentiating this, we bring down the power, reduce the power by 1, so bring down the 3, so the front is a 2 times 3, reduce the power by 1. Remembering the trick that if it's just a number times the letter just disappears. Work out the gradient. Well, that is exactly what this dy by dx is. This is the gradient. So I'm going to sub in the x value into my dy by dx. So 6 lots of 2 squared minus 6. It's 24 minus 6. So my gradient at that point is 18. Find the x-coordinate of the points where the gradient is 7.5. Well, that is again using our dy by dx. 6x squared minus 6 equals the 7.5. A bit of algebraic working here, adding on 6. Dividing by 6, and now it makes sense to now be in fractions rather than mixed numbers. So x is the square root of that. Remember, square rooting, plus or minus, and we did have the hint in the question that it did say find the coordinates, implying that there were multiple answers. I showed clear algebraic working. I didn't do any cheating or skipping of steps. 18. Probability. 2 fair 6-sided dice are thrown. The total is the sum of the numbers that each dice lands on. Work out the probability the total is 4. Well, there's a few different combinations to lead to 4. We can have 2 then 2, we can have 1 then 3, or 3 then 1. So 3 possibilities which leads to this total of 4. Each of these has a probability of a sixth times a sixth. So each one has a 1 out of 36. There are 3 of them. So you've got 3 out of 36, which equals a 12th. The probability of 4 is 1/12. I don't need to calculate it for each and every one of them. Each pair gives the same probability. 3 people each throw the 2 dice. Work out the probability that none of them get a total of 4. Well, the probability that one of them doesn't is 11 out of 12. So we're saying the first one doesn't, and the second one doesn't, and the third one doesn't. If you recall from probability independent events, when you say and, you multiply those probabilities, or you could just cube the 11 out of 12. I don't know my cube numbers quite that high, so my calculator helps me out, giving 1331 over 1728. Again, just as we go, we should be checking how many marks, checking that the amount of work we've done is comparable to how much credit they give us. Here's our classic simultaneous quadratic and linear. an incredibly pleasant one this time, because y is in such a pleasant position. So I'm just going to sub in the y into the second one, making an equation purely in terms of x. And now actually we see the question isn't quite as pleasant as we hoped. This is a very unpleasant to factorize quadratic equation. Now the question does say give your answers to 2dp, which is giving me the impression that this will not factorize. I'm just going to have a quick little think to check if it does, because factorizing is easier than the formula if you can spot them quickly. 5 and 1, 1 and 4 won't make a 3. 5 and 1, 2 and 2 will make 10 and 2, which again does not make 3. So unfortunately I'm quite convinced that we have to use the quadratic formula. Now you should definitely write this out in full for the examiners to see that you've subbed everything in to the right place. Again, this is on your formula sheet on the front page, so you don't need to memorize this formula. However, the more you use it and the more familiar you get, the more efficient you will be with using it. Into my calculator, my first x value comes out as 1.24. I'm going to put a couple more decimal places because I haven't got to my answer yet. I don't want to round too early. And then change into the negative sign in my quadratic formula. I get the equivalent negative solution as well. Simultaneous equations, I need both the x and the y value. Now I can use the second one of these, or the first actually, both are equivalent. Second one looks nicer because it's a linear equation, so I need to do 3 times the 1.24 etc, then add 4. Ideally you try and use the answer function in your calculator as much as possible to not lose any accuracy. If you are using what you've written down, make sure you've got more decimal places than what is required at the end. So those are my y values as well. To quote my final answers, I'm going to give them as coordinates to the degree of accuracy that they desire, to 2dp. So there's my first pair, and then my second pair to 2 decimal places. Quite an efficient style of question once you've got the feeling for these quadratic simultaneous. A third question, quite near the end of the paper. Show that can be written in that form. You've got the dreaded show that, which means we can't really cheat. We could type that into our calculator instantly, but that won't help us because we won't get our working marks. So I'm going to be very clear with all of my working here. First thing we should always do whenever we see surd questions is try and simplify all the surds in use. And we're looking for a square number and another number to make the 50 and the 18. Unfortunately, they both come out as multiples of root 2. So I can go back to my original over 4, put in the simplified versions, and I'm doing this with unpleasant amounts of detail, even though I do make typos there, to ensure that I get all of the working marks. So we've got to what we should notice is the most simple version, root 2 over 2. However, that's not what the question wanted. It wanted 1 over a square root. Now you might recognize what this is as 1 over a square root, but let's do the working anyway. This is kind of a reverse rationalizing the denominator. This time I'm rationalizing the numerator. Root 2 times root 2 on the top, giving just 2's. Let me notice a spare 2 on the denominator, cancels with that 2 we created in the top, and we have our final answer as 1 over root 2. As you start doing some more trig at higher levels, you'll notice that 1 over root 2 and root 2 over 2 pop up quite frequently. Question 21, another triangle question. This should be thinking at this point in the paper, sine and cosine rule. We want the area of triangle ABC. Well, that's going to have to use the half AB sine C formula. So that's a half of 7 times 10 times sine of the angle. Typing that into my calculator, giving me an answer of 33.8, and that's the 3 sig figure. I'm going to write down a few more. Again, this is just to show the examiner I have got it right before I round it. We then want the angle of BAC. So that's asking for this angle at A on the picture. Now this actually is quite unfortunate in the way it's set up. Normally when finding angles we'd quite like to use sine rule, which requires these opposite pairs. Now unfortunately I can't use sine rule because I don't have the side AB. So I'm going to have to use cosine rule first to find that side AB. So that side squared is the A squared plus, or A squared equals B squared plus C squared minus 2 lots of BC cos 105. Now you could relabel on the triangle. I know that's very helpful to a lot. Once you've used these enough, the labeling is there just to be able to write down the formula more than anything else. That squared value comes out as 285, and therefore the length AB is the square root of that is 13.6. I'm going to try and keep that in my calculator because I know I need to use it again later on. Now to find that angle, I'm going to use the sine rule with my newfound pair that I've just created. If I want to find the angle, I'd like to put the sine on the top. So that's sine over the opposite side equals sine over the opposite side. So sine theta is 10 lots of multiplying up of that fraction, and this is where keeping that 13.6 in your calculator is quite useful, using the answer function, giving us more horrible decimals, but I want the value of theta, so it's sine inverse of that answer, giving me 45.2. Now I've noticed I'm at the bottom of the page. It doesn't have an answer line, which probably means there's more working space on the next page, which actually makes me more confident because this did not seem like quite a small question. And we'll see, yep, there's the answer line over there, and the fact that it was worth 5 marks to do cosine and sine rule. Checking the rounding to 1 dp, 45.2. Of course, in the booklet, those should be adjacent pages, and you won't fall into that same confusion. Simplifying algebraic fractions, we want to factorize everything. On the top, I can see a common factor of 3 straight away, leaving behind 4x squared minus 1. The denominator, very unpleasant, has the x squared in front, a number in front of the x squared, so either split the middle or to try and make something up. The only way we can get an odd number is if I have an odd not times by an even. It's going to have a 1 times a 3 from the 6x squared, so it has to be a 2 and a 3, which I think has to be that way around. That gives me 8 and 3. I want to have a positive 8 and a negative 3. I haven't factorized the top fully yet. Notice that is a difference of 2 squares into 2x minus 1, 2x plus 1. And if we had done that numerator first, arguably the much easier part of this, we would notice that we had to have, just because it is a question, a common factor in the top and bottom. So we would have known we had to have either 2x plus 1 or 2x minus 1 in the denominator. Well, it's the 2x minus 1 that we have, so we can cancel those out. We don't need to re-expand the numerator, and that is our simplest version. Notice we can't cancel the 3 with the 3 in the bottom, because that 3 in the denominator is not common to the 4 as well. That is our final answer there. 3 marks, which seems reasonable for what we have done. Question 23. F is a function, and I think this is the last question. We've got that solid line at the bottom with total 100 marks, so we know we're right at the end of the paper now. F is a function such that f of x equals root 4 minus x, and the f of x is positive. State the range which must be excluded. So for square roots, we're not allowed to square root a negative number. So we have to have the fact that 4 minus 2x has to be greater than or equal to 0. If we're looking for what's excluded, we're not allowed this to be negative. So the values which we can exclude is when x is greater than 4. Inverse function. Our technique is set it equal to y. We're going to try and rearrange, squaring both sides. We add the x and subtract the y squared. I've managed to swap the subject. So then f inverse of x. We have to write this one in terms of x, so we're going to swap the y with the x to get the inverse function. And notice that the inverse of a square rooty thing is a quadratic-y thing. G is another function such that negative quadratic 5 minus x, x minus 1. The composite has a domain greater than or equal to 3, and we want to try and find f of g of x. So my first line of work, and I'm going to actually write it like that with those extra brackets. So it's f of that quadratic-y nonsense. Now f, you'll recall, is the square root of 4 minus x. Well, my x now is that double bracket. We want it in its simplest form, so I'm going to have to do a little bit of expanding and careful simplification. I'm going to expand with FOIL first, and then deal with the negative sign afterwards. The x times the x in the middle gives us the negative x squared. We're going to have a 5 times an x. We're going to have a minus 1 times a minus x. And finally, a 5 times minus 1, all square rooted. So that's 4 using the minus sign now. Times by minus 1 just swaps the sign. We had plus 6x, that's minus 6x. We had a minus 5, so that becomes a plus 5. And finally, simplifying that final step, plus 9. Now we could think that we're finished there actually, but no. This is actually quite sneaky, and I hope one or two of you may have noticed this as we got here, that is a perfect square inside, and we're left with x minus 3 from the square root of that bracket squared. A very sneaky final thing to try and catch us out right at the end. That's the end of that paper. If you do have any questions or you've spotted any silly mistakes, please do contact me. Otherwise, have a wonderful rest of your day.